Hello guys, myself Meet Nagadia, and today we'll be doing an amazing project that is a classification project. And so today's topic will be Parkinson disease prediction using XGBoost. So basically, Parkinson disease is a progressive disorder of central nervous system affecting the movement, including the tremors and stiffness. It has five stages to it, and this is the image where we can see what are the symptoms of this disease. So basically, slow movement, rigid muscles, loss of automatic movements, speed changes, writing changes. So these are some of the symptoms that occurs when a person or a patient has Parkinson disease. So in this project, we will be using XGBoost to classify based on the data that we collect to detect whether a person or a patient has Parkinson disease or not. So first of all, we'll just import all the necessary libraries, which may include NumPy for converting data into NumPy array and pandas to load CSV. Then we need Seaborn as well as Matplotlib for some visualization. Then we need XGBoost. So here is our model, XGBoost model. And then we need pre-processing min-max scalar. We are using min-max scalar here. And then from model selection, we need train test split. We will be splitting our data using train test split. Then we need sklearn matrices, matrix for accuracy score, confusion matrix, classification report, ROC, AUC curve, plot ROC curve, and plot confusion matrix. So these are the some of the evaluations. So we'll just run it. So here our successfully run the necessary libraries. Now we'll move on to load our dataset. So we have successfully load our data set. Then we'll explore our data. So here basically we'll first print the column names that are available in the data set using dot columns. So it will give us the name of the columns that are present in the data set. So here are the names of the columns. Now what we'll do is we'll check the size of the data. For that we will use data.shape. So this will give us the row and the column, the number of rows and number of columns. Now we'll print the first 5 rows of the dataset using .head function. It will display the first 5 rows from the dataset, and similarly .tail will give us the last 5 rows of the dataset. So these are the last 5. So now we will check the information about the dataset. So what dataset looks like. So it will give just a small preview about how our dataset looks like. So now we'll check for data types. So for that we will use D types. So it will give us the data type of the uh, uh, rows that are present. So for example, for columns that are present, so for example spread 1, so it contains float value. Spread 2, it again contains float value. So most of the contains float value except status, which is our target variable, it is integer. So now we have gone through our data set, so we will just check for the null values. If there is any present, then we will deal with it. So as we can see, everything is 0. How can this happen is using is null to check whether the column presents a missing value or not, and then we'll write sum. So it will directly give us the value if there is any. So if we just write data dot is null, then it will return the values in true false manner, in boolean values. So here we can see it gives us the whole data set with the boolean values. So that might be a hectic task to find whether the column has a null value or not. So we use dot sum function. So it will directly give us the count if the uh, row contains or if the column contains any null values. So now since we don't have any null values, so we don't need to pre-process it now. but we need to pre-process it further using min-max scaler. So now let's move on to EDA part. So here we'll just first draw the histogram of the dataset. Histogram of the dataset using data.hist. So it will give us the histogram, and we have specified the fixed size. So according to the fixed size, it will plot us the histogram. So this is the histogram of all the columns. Now we will plot the pair plot using Seaborn. That's why we used both of them. So this is our Seaborn pair plot, as we can see. Now we will move on to find correlation between the data and then plot the correlation using the heat map. So first of all, let's find the correlation. So this is how the correlation looks like. And as we can see, if the column and the row matches itself, it will give the value as 1. So now let's plot it. So this will give us the pair plot type. So it is giving us the bar type chart. Now we will use heat map to get a bigger picture so that we can know how much a column is related to the row. So this is what the heat map of correlation looks like. So now what we'll do is we'll get the features and labels from the data frame, that is our data set, and the features are all the columns except status, because the status is the column that is our target variable, which will let us know whether the patient has Parkinson or not. So for that, what we'll do is we'll create a label called features, which is equals to data.log, and we'll take the everything except status. So here this thing will run properly. Yep. So now what we'll create, we create a label and value variable called label, and then it will store the status. The status column has value 0 and 1 as labels. Let's get the count of these labels for both 0 and 1. So here we'll just print the we can say the labels that are present, so that we can know how much 1 is there and how much 0 is there. So this is the count. We have 147 as 1 and 48 as 0. So now what we'll do is we'll initialize a min-max scaler and scale the features to between -1 to 1 to normalize them. The min-max scaler transforms features by scaling them to a given range. The fit underscore transform method fits to the data and then transform it. We don't need the scales to the label. We don't need to scale the label. So first we use scalar as an, and then we'll initialize it to -1 to 1, and then we'll use the scalar dot fit transform, and then we'll give our features. If you remember, features is the whole data set except the status, because status is the label, and we'll keep the y as status, y as labels, and will not use the min max scalar on it. So as we have now transformed our data, so this was actually the pre-processing of data. So let me just create a label here. It is pre-processing data. Pre-processing data, and now we'll just run it. So our pre-processing is done, and we are just using min-max scalar to pre-process and nothing else, because we don't have null values, so we don't need to deal with it. So now what we'll do is we'll split our data into training and testing data. We can also create a validation data, but since the data is small, we'll just keep it to training and testing. So we are keeping a split of 20%. That means 80% would be our training data and 20% would be testing data. So now we will build our XGBoost model. So initializing an XGBoost model, and then we will train the model. This classes uses extreme gradient boosting, using gradient boosting algorithms for data science problems. So if it falls under the category of ensemble learning in machine learning, where we train and predict using many models to produce one superior output. So XG model is an type of ensemble learnings where we use, rather than use single model, we use different, or we can say we can use multiple models to create the output, and then we'll choose the one that is superior one. So now we'll initialize our model and we'll feed it with the training x train and y train, x train and y train. Yep. So our it is giving an just a warning, so we can ignore it, and then we'll predict the values for our x test data, and then we'll take the accuracy score using the among the testing data what it has predicted, and as we can see our accuracy is around 92.30, so it is very good. And also you can create a confusion matrix based on the prediction that is made on the test data. So this is the prediction. It correctly predicts 5 times 0 and 31 times 1. So, and these are the false values that it has predicted. Then we will print the classification report using classification underscore report y test, y underscore test, and y underscore predict. So based on the actual labels and then what it has predicted, we have created the confusion matrix where it not only just give us the accuracy but also the precision recall and F1 score. So now we will plot the ROC curve based on the test data. So this is the AUC curve. Then we'll do one thing, is this is completely optional. What we can do is to try our model, we can randomly take values and then feed it to model to predict whether the values that are given are classified as 0 or 1, that is, does the patient have Parkinson or not, based on the random values we take. So here I have taken them random values. We can play with the values to get to know the output. So we have taken the new input, which is considering of this random values. Then we'll put it into the model and let it predict the new input. So as we can see here, it is giving 1, and here label 1 means true, that person or the patient has Parkinson. 0 means it does not have. So as we have already got 1, so it means that it is true. So it is pretty much good, and as we can see that it is performing very well. We got about 92% of accuracy on the XGBoost model. And yep, that's it. This was all about XGBoost on Parkinson disease, where I have more focused on the disease rather than just the model. So that's it, guys, and if you have any doubts or comments, please let me know in the comments, and the code of this would be in description below. I have used Anaconda here. We can use Google Colab or Kaggle notebooks, whatever we like. So that's of it, guys. Hope to see you in next one. Thank you.